Change of base. Before we talk about change of base, let's do some checks. If I have log of m to the base k, and this is equal to, let's say, a, then I want to change this to indices. If I do, I'll get m is equal to k to the power a. Now, I will also want to find logarithm of both sides. So the base should be the same. So I'll have log m, let's say, to the base e, and that is equal to log to the base e of k to the power a. Okay, so as we know, I can drop the exponent and obtain log m to the base e is equal to a log k to the base e. Now, my next task is to make a the subject. So I divide through by log k to the base e. So I'll have log of m to the base e divided by log of k to the base e, which is equal to a. So let's say a is equal to log m base e divided by log k base e. Now remember that a is log m base k, so we substitute, and that gives us log m base k is equal to log m base e divided by log k base e. Now let's observe carefully the expression we have obtained. This equation that we have obtained, if you observe carefully, you realize that we have splitted originally the number m to the base k of a log. So log of m to the base k. What we have done is we have taken log of m, and then we have also taken log of k. But this time, each one has its own base. And here, this is what we have: log of m to the base e, log of k to the base e. So we have changed this expression. It's like we have splitted this expression and then given each of them a new base, but the base happened to be the same for both of them. Have you seen what I'm saying? So initially, m was just the value of the log, and then k was just the base. But you see that I have spread the two. M has become still value on its own, but the base has changed to e. And then k has become a value on its own, and then the base has become e. What that means is that in logarithm, this is what we call change of base. In logarithm, you can change the base of a log value. For instance, if you have log 5 base 2, this one can be written as log 5 divided by log 2. In this case, I've used a common base of 10 for both of them. So that is what it means. Solve the equations. So for our first equation, we have log to the base s of 0.028, which is equal to 3. So we solve. Log to the base x of 0.028 is equal to 3. So the first thing I will do is to write the left hand side by changing the base. So I'll write it as log 0.028 divided by log x. I believe if I didn't write the base, you understand that it is in base 10. That is equal to 3 as we see. So I will multiply through by log x to obtain log 0.028 is equal to 3 log x. So I'll continue by dividing through by 3. That gives me log x is equal to log 0.028 divided by 3. And this gives me log x is equal to negative 1.5528 divided by 3, which gives me log x is equal to negative 0.5176. And I would change this result to indices. Remember, log s is to the base 10. So x here will be equal to 10 to the power negative 0.5176. And that my x will be 0.3037 as the final answer. Okay, so for example 2, I'll continue from here, but this time I'm using a different color. I have log to the base 10 of x is equal to log to the base 5 of 2x. So I'll change the right hand side. I'll change the base of that. So I'll have log x base 10 is equal to log 2x, which is in base 10, over log 5, which is also in base 10. Okay, so I'll continue. I'll clear the fraction here. So I'll have log x base 10 multiplying log 5 also base 10. This is equal to log 2x also in base 10. Alright, I hope you are following. Log 5 base 10 will give me 0.699. So when I multiply, I'll get 0.699 multiplying log x to the base 10, which is also equal to. And remember, the product, when you come to the right side, the product 2x can be separated by addition. So we have log 2 base 10 plus log x also base 10. So now I have log x, log s on either side. I'll group like this. That gives me 0.699 log x base 10 minus log x base 10. And this is equal to log 2 base 10. Okay, so when I do the subtraction, I'll get negative 0.301 log x to the base 10. And this is equal to log 2 to the base 10. Okay, so from here I can also find the value of log 2 to the base 10 and then do the division. So log s to the base 10 will be equal to log 2 to the base 10, which should be 0.0 301, and I'm dividing by negative 0.301. So I get log x base 10 to be equal to negative 1. And when I change this to indices, I'll get x is equal to 10 to the power minus 1. And from here, permit me to use the small space. Okay, so x is equal to 10 to the power 1, negative 1, and that's 10, 1 over 10 as the answer. So it says find without using tables or calculators the value of the expression here. That is a fraction with numerator log to the base 3 of 27 minus log to the base 1 over 4 of 64, and the denominator log to the base 3 of 1 over 81. Okay, so let's solve. Okay, I will rewrite it here. Log to the base 3 of 27 minus log to the base 1 over 4 of 64. Then everything here is divided by log to the base 3 of 1 over 81. So when I look at log 27 to the base 3, I believe there is a way of making that simple. So I'll write that as log 3 to the power 3, and then it is in base 3. Then for this side, log to the base 1 over 4, 64, I can't simplify it, but the denominator can also be simplified. Log to the base 3, and 81 can be written as 3 to the power 4, and that's, in this case, we can write it as 3 to the power negative 4 because of the inverse of it. Okay, so here I will simplify them as 3 log 3 base 3 minus log 64 to the base 1 over 4 divided by negative 4 log 3 to the base 3. So these ones, as we see them, we will have as 3 minus log 64 base 1 over 4, and then negative 4. So what I have now, I think the best option for me to do is to change the base of the expression I couldn't simplify. And that I'm going to write 3 minus, okay, so I'm going to have it as log 64 divided by log 1 over 4. Okay, and then all divided by negative 4. Okay, so log 64 becomes, so 3 minus, then log 64 becomes log 4 to the power 3, and then log 1 over 4 becomes log 4 to the power minus 1 divided by negative 4. So when I drop, I'll get 3 minus 3 over negative 1. So that's what I have here, everything divided by minus 4. This negative 1 here becomes 3 minus, plus 3 divided by negative 4. So I have 6 divided by negative 4. So comes negative 6 over 4 as the answer. So if I simplify, then I have negative 3 over 2 as the answer. Find the solution of the equation log to the base 2 of x plus 4 log to the base s of 2 is equal to 5. Okay, so let's solve our solution. Log to the base 2 of x plus 4 times log to the base x of 2. And this expression is equal to 5. Okay, so as we see the log x to the base 2 and log 2 to the base x, they are just funny. We have to change the base of one of them. Okay, so we have it as log s to the base 2 plus 4 times, then I'll change the base of this as log 2, and I will use base 2 to the base 2 divided by log x to the base 2, and this expression is equal to 5. Okay, so let's simplify that. Have log x to the base 2 plus, so this numerator becomes 1, and 4 times 1 is 4 divided by log x to the base 2. This is equal to 5. Okay, so from here I will let log s to the base 2 be equal to m. If that happens, my equation becomes m plus 4 over m is equal to 5. So from here I'll clear the fraction, and that I'll multiply through by m. That gives me m squared plus 4 is equal to 5m. So I'll group them properly as m squared minus 5m plus 4 is equal to 0. So now I have quadratic equation to solve. So here I will find factors of 4 that sum up to negative 5, and that will be negative 1, negative 4. So I have m squared minus m minus 4m plus 4 is equal to 0. So here I'll have m out, m plus minus 1. Here I have negative 4 out. I have m minus 1 is equal to 0. So they become m minus 4 multiplying m minus 1, which is equal to 0. Okay, so it means that m minus 4 is equal to 0, which means m is equal to 4. Or I'll have m minus 1 is equal to 0, which means m is equal to 1. But let's remember that we used m to represent log s to the base 2. Therefore, since m is equal to log x to the base 2, then when m is equal to 1, log x to the base 2 will be equal to 1. And I'll change this to indices, and that will give me s is equal to 2 to the power 1, which is 2, and that my x is 2. Then when m is equal to 4, I'll have log x to the base 2 to be equal to 4, and I'll change this to indices. That gives me x is equal to 2 to the power 4, which gives me s is equal to 16. Okay, so that's how we go about it. Find the solution of the equation log to the base 3 of an expression in bracket 2 minus 3x, and this is equal to log to the base 9 of an expression in bracket 6x squared minus 19x plus 2. Okay, so let's solve our solution. So we have the expression as log to the base 3 of 2 minus 3x, and this is equal to log to the base 9 of an expression in brackets 6x squared minus 19x plus 2. Okay, so here I'll maintain the left hand side as log to the base 3 of 2 minus 3x, and then change the base of the right hand side to base 3. That gives me log to the base 3 of expression in brackets 6x squared minus 19x plus 2. This is divided by log to the base 3 of 9. Okay, so I'll rewrite the denominator, which is log to the base 3 of 9. So here I have log to the base 3, 2 minus 3x is equal to log to the base 3, 6x squared minus 19x plus 2. And then I will divide by log to the base 3 of 3 to the power 2. So when I drop the exponents, what will happen is let me write this. So 6x squared minus 19x plus 2. So when I drop the exponents, what will happen is I'll get here to be 2. I hope you already know this. And I'll multiply through by the 2. That gives me 2 log to the base 3, 2 minus 3x. And this is equal to log to the base 3, 6x squared minus 19x plus 2. Okay, I will continue. And then the left hand side, I'll write it as log to the base 3 of 2 minus 3x all to the power 2. And this is equal to log to the base 3 of 6x squared minus 19x plus 2. Now when you look at the equation, you see that there is log to the base 3 on both sides. So I'll find antilog and obtain 2 minus 3x all squared is equal to 6x squared minus 19x plus 2. So I will expand this bracket. 2 squared is 4. 2 times 3x is negative. 2 times negative 3x is negative 6x. Then times 2, which gives me negative 12x plus 9s squared. This is equal to 6s squared minus 19x plus 2. So I will group like terms and then simplify. So I have 9x squared minus 6s squared minus 12x plus 19x plus 4 minus 2. And this is equal to 0. Here I have 3s squared, and then here is going to be plus 7x plus 2 is equal to 0. So I solved the quadratic equation, and here the coefficients of x squared is 3 and the constant is 2. So I'll multiply them and get 6. So I will need factors of 6 that sum up to 7. And that will be 1 and 6. So here I'll have 3x squared plus 6x plus x plus 2 is equal to 0. So here I'll bring 3x out, have x plus 2. And then here 1 out, and I'll have x plus 2, which is equal to 0. So s 3x plus 1, and then x plus 2 is equal to 0. So when I solve, I'll get x is equal to negative 2, or x is equal to negative 1 over 3 as my answer. Solve the following simultaneous equations. Okay, so solution. The first equation, we have 4 divided by log s base 2 minus 3 log y base 3, and this is equal to minus 2. I will change the base of log s base 2 and then choose base x. So 4 divided by log s base x over log 2 base x. So this minus log y base 3 is equal to minus 2. 4 over 1 divided by log 2 base x minus 3 log y base 3 is equal to minus 2. So here I simplify, and then that will give me 4 log 2 base x minus 3 log y base 3 equal to negative 2. So that becomes my first equation, equation 1. Then the second one, I have 2 log 2 base x plus 1 over log 3 base y is equal to 4. So here I'll maintain 2 log 2 base x, and I'll change the base of log 3 base y and then make it and choose the base of 3. So I'll have log 3 base 3 divided by log y base 3. This is equal to 4. So I have 2 log 2 base x plus 1 over 1 over log y base 3 is equal to 4. This becomes 2 log 2 base x plus log y base 3 is equal to 4. That becomes my equation 2. So looking at the terms in equations 1 and 2, they are very similar. And so I will make representation. So I will let log 2 base x be equal to a, and then log y base 3 be equal to b. So with that, my equation 1 becomes 4a minus 3b is equal to 2. I'll still maintain that as my equation 1. So the labeling here, I can cancel the equation 1 here. And then for equation 2, it becomes 2a plus b is equal to 4. Sorry, the first one should be is equal to negative 2. And that also becomes my equation 2, and I clean the equation 2 label for this one. So now I have to solve the two simultaneously. Now I solve the two equations simultaneously, and what I will do is I will multiply equation 2 by 3 and add the result to equation 1. So I'll write it as equation 2 multiplied by 3, and then the result I get, I'm adding it to equation 1. So when I do the multiplication, I'm going to get 6a plus 3b is equal to 12. And then I'm adding this to 4a minus 3b is equal to negative 2. So when I do the addition, I'm going to obtain 10a is equal to 10. And that means that a is equal to 10 over 10, which is equal to 1. Now, to get the value of b, I'll substitute a into equation 2. So, substituting a, which is equal to 1, into equation 2. I get 2 times 1 plus b is equal to 4. That means that b is equal to 4 minus 2. B is equal to 2. Now, let's remember that we used a and b to represent something. So, we continue from there. Thus, we have log 2 to the base x is equal to a. And now that we have a to be 1, we will say log 2 to the base x is equal to 1. Now I will change this expression to indices, and that will give me 2 is equal to x to the power 1, which is the same as 2 is equal to x. So our x is equal to 2. And then the second one, I have log y to the base 3 is equal to b. And that means log y to the base 3 is equal to 2. And if I change this to indices, I'm getting y is equal to 3 to the power 2. Thus, y is equal to 9 as the answer. If log to the base 10 of the expression 1.8 to the power 2x is equal to 5, evaluate log to the base 4 of the expression s to the power 27. Okay, so solution. We have log to the base 10 of 1.8 to the power 2x is equal to 5. Okay, so what I will do is to drop the exponent. That gives me 2x log 1.8 base 10 is equal to 5. And that's, if I decide to divide through by 2, I'll get s log 1.8 to the base 10 is equal to 5 over 2. And I will also divide through by log 1.8 to the base 10. That will give me x is equal to 5 divided by 2 log 1.8 to the base 10. So what is the value of x? 9.7935. Okay, so once I know the value of x, then I will be able to evaluate log to the base 4 of x to the power 27. So first of all, I will drop the exponent as 27 log to the base 4 of x, and then I will do my substitution. So 27 log 9.7935 base 4. Okay, so I will be able to use base 10 to make the whole thing simpler. So 27 multiplying log 9.7935 divided by log 4, and this gives me 44.435 as the final answer.